This video covers chapter 2 of the textbook for GCSE, and we'll go through the topics for this. So, writing one quantity as a fraction of another. So the way that we do that is these are normally questions that say out of. You're looking for the phrase, not always, but often out of. So let's say, for example, someone got 16 out of 40 in a test, and we want to write it as a percentage. So out of basically means you write it like this: 16 over 40. So think of that line as meaning out of. And we want to change that fraction to a percentage, and the way we can do that is we can do 16 divided by 40. And then once we've done that, we've got a decimal, we can then times it by 100. So that can be done on a calculator. So if I do 16 divided by 40 and then times that by 100, I get 40%. So I actually got 0.4 and then times that by 100, and that became 40%. If you didn't have a calculator, then what we would do is we would try and simplify that fraction. We want to change it so it's out of 100. So I could do that by dividing both of these by 4. So I get 4 over 10. That I can change to over 100 by multiplying by 10. So that's my aim, to get it over 100. 40 over 100. And there's the percentage there. Yeah, the number at the top. So I get the same answer either way. So if you're writing one quantity as a fraction of another, basically you write one quantity over, literally over, as you do in a fraction, over the other. That will give you a fraction. Then you want to change that to a decimal. So you can do that by doing division. And then from the decimal, you then want to times it by 100 to change it to a percentage. The next bit is about adding, subtracting and multiplying fractions. So basically the 4 rules to do with fractions. If I want to add or subtract fractions, what I need to do first is I need to make the denominators the same. I'll just put make bottom the same. So that's the denominator. Then we either add or subtract the numerators. So here's some examples. Let's say I had 5 over 6 minus a third. So in this case, I will just need to multiply the second fraction, the top and bottom, by 2. That will make both the denominators the same. So the first one stays as 5 over 6, then minus 2 over 6. Then you just subtract the numerators, and that gives me 3 over 6, and that simplifies to a half. It may be that I have mixed numbers, so let's say I had 2.5 plus 1 and 2/5. So the first thing we would do is change them to improper fractions. So you would have 7 over 3 plus, and the second one also becomes 7 over 5. We want to make the denominators the same. This time I need to multiply both fractions. I'll times this one by 5, this one by 3, and that way I get 15 at the bottom of both. So I'll get 35 over 15 plus 21 over 15. That will give me 56 over 15. 56 over 15. And what I'm going to do, I'm going to change that back to a mixed number. So I'll say 15 goes into 56 3 times. That's 45, 3 times 15. So that leaves a remainder of 11. So it'll be 11 over 15. Okay, so that's how we add and subtract fractions. Make the denominators the same, which may involve multiplying one or both of the fractions. Then either add or subtract the numerators, but if you've got any mixed numbers, change them to improper fractions. And in fact, that's the same when we multiply or divide. So the same rule applies with these mixed numbers. So I'll just write it here, mixed numbers. We want to change them. When we do these calculations, we want to change them to improper fractions. So we're always going to have to do that. And you might need to do that at the end to change improper fraction back to mixed number. It all depends on the question. Right, so multiplying. I think these are actually easier than adding or subtracting because there is no need to make the denominators the same. So we do not need to make the denominators the same. So don't bother doing it. You'll be wasting your time. So what do we do? Well, if we're multiplying, we just take the top number of the first fraction, times it by the top number of the second fraction, and we take the bottom number of the first fraction and multiply it by the bottom number of the second fraction. So if I've got something like this, 5 over 6 times 7 over 8, well, that's going to be 5 times 7 is 35. 6 times 8 is 48, so that's done. Easy. If I've got a mixed number, so let's say I had 3.5 times by 2 3/5. So change them to mixed numbers first, sorry, improper fractions first. So that would be 6 7 over 2 times by 2 times 5 is 10, 13 over 5. And then we do the same thing again. 7 times 13, now I'm going to have to I'll use my calculator to do that, because I've just made up a question and the numbers are quite big. 7 times 13 is 91. So you've got 91 over 10. So we could leave it like that, or we could change that into 10 goes into 91 9 times, and we have a remainder of 1 over 10. Okay, so now let's look at divisions, and we use this KFC. So K stands for keep the first fraction the same. You don't touch it, you leave it as it is. Keep the first fraction the same. The F stands for flip the second fraction. Now when we flip a fraction over, it's called the reciprocal. So we'll just write that down. Reciprocal. I'll just write that here. So that's RECIPROCAL. So that's what we call it when we flip a fraction over. So if I've got 2 over 5, the reciprocal is 5 over 2. Yeah, so if you ask for reciprocal, that's what it means. And then the C in the KFC stands for change. What that means is we're going to change the divide to multiply, and then just do what we did for the multiplications. So if I had something like 7 over 10 divided by 5 over 9, keep the first fraction, 7 over 10, flip the second fraction, 9 over 5, change the sign. So now it just becomes a multiplication. 7 times 9 is 63 over 50. I could change that to a mixed number. 50 goes into 63 once with a remainder of 13. Yeah, so that is adding, subtracting, multiplying and dividing fractions. Next comes calculating a percentage increase or decrease. So percentage increase or decrease. So there's a couple of ways we can do this. we can work out what the percentage is. So work out the percentage. Now, useful things to help you work out a percentage without a calculator is to find 10% you divide by 10. To find 1% you divide by 100. To find 50% you divide by 2. To find 25%, for example, you can divide by 4. Lots of others, 5%. An easy way to do that is just half of 10%. So work out 10%, find half of it. And then work out those percentages, and then the next thing you do is either add on or subtract the amount from the original quantity. Yeah, so if you had something that was a 10% increase, you work out 10% of that number and then add it on. If it was a 5% decrease, you'd work out that 5% and subtract it. So here's an example. Let's say I wanted to increase £72 by 5%. Well, I know that 10% of 72 is 7.2. I'll just divide it by 10. 5% is going to be half of that. So half of 7.2, which is 3.6. So if I'm increasing it by 5%, I want to do 72 and add 3.6, and then I get 75.6, and because this is pounds and pence, it would be £75.60. Yeah, and if that was a 5% decrease instead, I will just take off 3.6 from 72 instead. So that's if you haven't got a calculator. Now, if we have got a calculator, then what we would do, we would use something called a multiplier. It makes doing a percentage increase or decrease much easier using multipliers, right? So how do we use multipliers? Step number 1, start with 100%. Yeah, always you start with 100%. Next thing that we do is add on or subtract the percentage increase or decrease, and then you'll have a number either above 100% or below 100%. Next step, divide by 100 to change into the multiplier. So we'll get some sort of decimal number, 1 point something or 0 point something, and that becomes a number we call the multiplier. And why do we call it the multiplier? Because we multiply the quantity by the multiplier. So now multiply the quantity by the multiplier. So let's do the last example, but using a multiplier. And that last example was, no, let's choose some different numbers. Let's say we want to decrease 16 by 23%. So what do? We start with 100%, always. Because it's a decrease, we subtract 23%. So 100 take away 23 leaves me with 77. So I've now got 77%. I need to change 77% to a decimal, or this multiplier by dividing it by 100. That gives me 0.77. And I take the amount that I started with, 16, and I now do 16 times by 0.77. That will decrease it by 23%. So if I do that, so 16 times by 0.77, and I get 12.32. Now if this question was increased by 23%, what would be different is that instead of 100 minus 23, I'd have 100 plus 23. I'd have 123% if this had increased. That would then be 1.23, and I would do 16 times by 1.23 to get an increase of 23%. Now the remaining sections are pretty much things that we've already done already. So if you want to compare proportions using percentages, that basically means either converting maybe a decimal or mainly a fraction into a percentage. So we'll just do like a little chart here about changing fractions into percentages. So if you want to change a fraction into a percentage, the first thing you need to do is to change it into a decimal. And the way that you do that is just, let's do an example. So if I had 8 over 15, I now would do 8 divided by 15. So we do a division. So I'll just put divide here. That would give me a decimal. So if I do 8 divided by 15, I get 0.53 recurring. 0.53 recurring. So this is just an example. And then from there you times it by 100 to change it into a percentage. So if I do 0.3553, sorry, recurring times 100, I'll get 53.3 recurring percent. And that means I can easily convert or compare any question which is an out of question, because an out of I'd write as a fraction. So let's say, for example, somebody got 8 out of 15 in a test and somebody else got 7 out of 10, and I want to work out who did better. I will go through this process of converting to decimal to percentage, and then it's easily done to compare the percentages rather than trying to compare fractions. The next bit we've also done, percentage multipliers to work out percentage calculations. Okay, I showed you how to do that when we did this, so that's done as well. Calculations with mixed numbers, well, I showed you how to do that when we were doing calculations with fractions. That's basically what it means. And then the last section is basically just putting this all together, yeah. Particularly if we're doing problems where we've got percentages, increases and decreases. And when we use the multipliers, it makes it really easy. I'll give you an example. Let's say we had a question that said a quantity is increased by 20%, then decreased by 10%. What is the overall percentage change? Now you might be tempted to think, oh well, if it's gone up by 20 and it's gone down by 10, well, it's the same as a 10% increase, but you would be incorrect. Now it just says a quantity, it doesn't give us a value. So I would always suggest on questions like this, just like we do with multipliers, start with 100, like 100%. And we're going to increase this by 20%. That means multiplying it by 1.20, because that is 100% plus 20%, which is a 20% increase. So let's do that. Well, actually, let's work out the next bit. Then a decrease of 10%. That would mean multiplying by 0.9 or 0.90, because that's 90%, and that's the same as 100% minus 10%, 10% decrease. And let's see what we end up with. So do 100 times by 1.20 times by 0.90, and I get 108. Now, if I started with 100, a bit like 100%, and I've gone up to 108, overall, that's an 8% increase. Yeah, using the number 100 made it really easy, because whatever number you finish with tells you what percentage it is, whether it's an increase or decrease, and it's gone up from 100 to 108. So actually, that's an 8% increase. So this is where multipliers become really powerful and make working really easy to do. And often you get these questions that say, you know, Samuel says he's increased by this percent and decreased by this percent. He says overall that's 5%. Is he right or wrong? Well, this is how you're going to find out whether that person is right or wrong. So this covers everything you need to know for chapter 2.